Hi everyone. Today we're going to study gradient vector. The gradient vector or gradient of the function f of xy is this formula. The notation inverted f is read as grad f or gradient of f or del f. So our formula here is read as gradient of f is equal to I times partial derivative of f with respect to x plus j times partial derivative of f with respect to y. For differentiable function f of x, y, z, the gradient of f is grad f equals I times partial derivative of f with respect to x plus j times partial derivative of f with respect to y plus k times partial derivative of f with respect to z. These are the working formulas. Example 1. If f of x, y, z equals x square y minus 2y square z power 3, find grad f at the point 1, -1, 2. Let us write our formula for the gradient of f. Now step 1, evaluate respective partial derivatives and substitute corresponding values. Let's begin with the partial derivative of f with respect to x. So the partial derivative of x squared y with respect to x is 2xy minus partial derivative of 2y squared z cubed. So this has no x variable, so this is considered to be constant. Derivative of a constant is 0. So the partial derivative of f with respect to x is 2xy. Now let us substitute the corresponding values. So we have now 2 times 1 times -1. Simplifying this, we have -2. Let's proceed with the partial derivative of f with respect to y. Partial derivative of x squared y is x squared minus partial derivative of 2y squared z cubed with respect to y is 4y z cubed. Substituting the values, we have now 1 squared minus 4 times -1 times 2 cubed. Simplifying this, we have now 1 plus 32, and 1 plus 32 is 33. We have now the partial derivative of f with respect to z. So partial derivative of x squared y is 0 minus partial derivative of 2y squared z cubed with respect to z. So this is now -6y squared z squared. Let us substitute the values. We have now -6 times the square of -1 times the square of 2. Simplifying this, we have -6 times 1 times 4. And the final answer is -24. Now step 2 is to substitute partial derivative values in grad f. So we have now grad f equals -2i plus 33j minus 24k. This is the final answer. Example 2, find the gradient of function f of x, y, z equals x squared plus y squared minus 2z squared plus z, ln z at the point 1, 1, 1. First, let us write the formula for the grad f. For step 1, let us evaluate respective partial derivatives and substitute corresponding values. Let's begin with the partial derivative of f with respect to x. Partial derivative of x squared with respect to x is 2x. The other three terms here have no variable x, so all of them are considered constant. Taking the derivative, it will get 0. So the value here is only 2x. Now let us substitute the corresponding value for x. We have now 2 times 1. The product is 2. Let's proceed. Partial derivative of f with respect to y. Partial derivative of x squared, this negative 2z squared, the z, ln z will be 0 because there is no y variable. So the derivative of y squared is 2y. Now let us substitute the corresponding value. This is now 2 times 1. So the product is 2. Now, partial derivative of f with respect to z. Looking here, there are two terms with z variable, while there are two terms also without z variable. So the x squared plus y squared, taking derivative, will get 0. Now, derivative of negative 2z squared will be negative 4z plus z ln z. This is a product. So let us apply the product formula. We copy the z multiplied by derivative of ln z, that is 1 over z, plus we copy ln z times derivative of z, that is 1. Simplifying further, we have now this negative 4z plus this value here is equal to 1 plus ln z. Let us now substitute the value for z. Negative 4 times 1 plus 1 plus ln 1. This ln 1 here is 0, so we can cancel this out. Negative 4 times 1 is negative 4 plus 1, it will give us negative 3. For step 2, let us substitute partial derivative values in gradient of f. So we have now grad f equals 2i plus 2j minus 3k. This is now the final answer. Today, we're going to study directional derivative. The directional derivative of a function f at a point P in the direction of the unit vector u is given by the formula df over ds equals grad f dot u. Remember that grad f equals I times partial derivative of f with respect to x plus j times partial derivative of f with respect to y plus k times partial derivative of f with respect to z. For the u, this is equal to the vector v all over the length of v. This is the working formula. Now, for the formal definition, we have the directional derivative of function f at the point p sub 0 of x sub 0, comma, y sub 0 in the direction of the unit vector u equals u sub 1 I plus u sub 2 j is the number, and this is our limit formula, provided the limit exists. Now example 1, find the directional derivative of f of x, y, z equals x squared yz plus 4xz squared plus xyz at point 1, 2, 3 in the direction of vector v equals 2I plus j minus k. We write here the formula for the directional derivative. That is df over ds equals gradient of f dot u. For step 1, let us evaluate the grad f. So the partial derivative of f with respect to x is 2xyz plus 4z squared plus yz. This quantity multiplied by I plus partial derivative of f with respect to y. That is x squared z plus xz. The quantity is multiplied by j plus partial derivative of f with respect to z. We have x squared y plus 8xz plus xy. The quantity is multiplied by k. Now at 1, 2, 3, which means we substitute the value of x as 1, the y as 2, and the z as 3. The graph f is simplified into 54i plus 6j plus 28k. Now step 2, let's evaluate the u, that is equal to v all over the length of v. So we have here u equals, we copy the vector 2I plus j minus k all over the length of the vector. We have now 2 square plus 1 square plus the square of negative 1. We can simplify the denominator into square root of 6. Then let us distribute the square root of 6 or the denominator to each of the terms of the numerator. So we have 2I over square root of 6 plus j over square root of 6 minus k over square root of 6. Now step 3, we are now ready to evaluate the df over ds, that is grad f dot u. So we have this 54i plus 6j plus 28k dot 2I over square root of 6 plus j over square root of 6 minus k over square root of 6. So we have now this 54 times 2 over square root of 6 plus 6 times 1 over square root of 6 plus 28 times negative 1 over square root of 6. We can simplify this into 108 over square root of 6 plus 6 over square root of 6 minus 28 over square root of 6. And the final answer here will be 86 over square root of 6. Example 2. Find the derivative of f of xy equals x e raised to y plus cosine of the quantity xy at the point 2, 0 in the direction of v equals 3i minus 4j. We write the formula for the df over ds. Now for step 1, let us evaluate the grad f equals I partial derivative of f with respect to x plus j times partial derivative of f with respect to y. In here, we don't have the k. So we have now the partial derivative of f with respect to x as e raised to y minus y times sine of the quantity xy. So we write here the I. Then plus the component j times the quantity partial derivative of f with respect to y. We have x times e raised to y minus x times sine of the quantity xy. Simplifying this, we substitute the value of x as 2, we substitute the value of y as 0 respectively. The value of the grad f is simplified into I plus 2j. Now let us evaluate u equals v over the length of v. That is for the step 2. So we have u equals, we copy the v, the 3i minus 4j, all over the square root 3 square plus the square of negative 4. The denominator is simplified into square root of 25, and that is equal to 5. Now let us distribute the denominator 5 to each of the terms of the numerator. So we have 3i over 5 minus 4j over 5. Now step 3. We are now ready to evaluate the df over ds. Let us substitute the corresponding values. So we have I plus 2j, 3i over 5 minus 4j over 5. And this is equal to 1 times 3 over 5 plus 2 times the quantity, negative 4 over 5. And this becomes 3 over 5 minus 8 over 5. That is simplified into negative 5 over 5. And this is equal to negative 1. This is the final answer. I hope you learned something from this video. See you again next time.